Hello, and welcome to the session on rounding numbers. What are we going to learn in this session? First, we'll understand what is it to round any number. Okay, what do we do when we round number to a desired place value? Then we'll understand how do we round integers to a desired number of place values. And finally, we'll understand how do we round decimals to a desired decimal place. Let's get started then. The prerequisite for this particular topic is your knowledge about place values. So let's do a quick recap. I'm sure all of you are aware of this particular concept, but let's do a quick recap. So if you have decimal at the center, the place values to the left of the decimals are called ones, tens, hundreds, thousands, 10,000s, 100,000s, and millions. We are all familiar with that, right? So the digit 3 is in the tens place, while the digit 2 is in the thousands place. How are the place values after the decimals? These are called tenths, hundreds, thousands, 10,000s, 100,000s, and millions. So digit 4 is in the hundreds place, whereas digit 8 is in the thousands place. We are all familiar with the place value of numbers, right? Well, now let's try and understand what is rounding numbers. For that, let's take a real life situation. Let's say we have two train stations, A and B, and there are 9 houses between these two train stations. Let's assume that the families in each of these houses go to the train station which is nearest to their home. So which of these houses will go to station A and which of them will go to station B? Well, that's pretty obvious, right? The first 4 houses are closest to station A and hence they will all go to station A. The last 4 houses are all closest to station B and hence they will all go to station B. Now the only confusion is about the house which is right in the middle because that is equidistant from both stations A and B. So where do you think the family of that particular house go? Now in real life, they can go to any of the stations. In fact, any of the houses can go to any of the stations. However, in a mathematical context, always remember that the house in the middle, the members of that family will always go to station B, the station on the right. Okay, in the mathematical context, okay, in actual real life, you never know. Okay, they can all go to whichever station they feel like. But in the mathematical context, okay, all the houses will go to the train stations which are closest to them. And the ones in the middle, okay, because it is equidistant from both, as a thumb rule, always remember the members of that family will always go to the train station on the right. Okay, in this case, B. Now, how is it relevant to rounding numbers? Okay, you'll understand this in a while. So let's say if I were to number each of these houses, including the two stations, as 70, 71, 72, and so on, all the way till 80, you would realize that numbers 71, 72, 73, 74, because they are closer to 70, they will all be rounded to 70. Whereas numbers 76, 77, 78, 79, because these numbers are closer to 80, they will all be rounded to 80. The only decision will be taken about number 75 because it is equidistant from 70 and 80. But always remember, in mathematical context, as a thumb rule, 75 will be rounded to 80. It will always be rounded up. That is how we round numbers to the nearest 10. Now we can enlarge the gamut and we can understand the same thing for rounding numbers closest to 100, right? Nearest to 100. All I need to do is number the stations A and B as, let's say, 200 and 300. And for each of the house numbers, I keep a gap of 10. So 210, 220, 230, and so on. So once again, the first 4 houses, that's numbers 210, 220, 230, and 240, are closer to 200. So they will all be rounded to 200 to the nearest 100. The last 4 houses, 260, 270, 280, and 290, will all be rounded to 300 to the nearest 100. And the house number 250, because it is equidistant from both of them, will again be rounded up to 300 and not down to 200. Okay, so the thumb rule is always the number which is right in the middle will always be rounded up, whichever be the context. Okay, nearest 100, 1000, or tens. Now, let us try and understand exactly how integers can be rounded to a desired number of place value. So let's take an example. We need to round 1672 to the nearest tens. You follow the steps which I'm telling you very meticulously, and you'll never go wrong in rounding numbers. The first step is to write the same number, 1672, 1672. What are we trying to round this to? We are trying to round this to the nearest tens. So the first step is to underline the tens place digit, which in this case is 7. Now, all the digits before 7, okay, or preceding 7, you need to put these as it is. Okay, so keep it same as in you put them as it is. So 1 and 6 will go as it is in the final answer. The digits which follow 7, okay, after 7, will all be replaced by 0. So each of those digits will be replaced by 0. In this case, there's only one digit after 7, which is 2. So we'll replace that with a 0. So now the only call we need to take is on the digit 7 itself. For that, we need to look at the next digit, okay, the digit on the right of 7, which in our case is 2. So what's the rule? The rule says if the digit on the right is 5 or more, you need to increase the underlying digit by 1, else you keep it the same. Because we have a 2 to the right of 7, which is not 5 or more, we keep the digit 7 as it is. So your final answer is the number 1672 rounded to nearest tens is 1670. Let's take one more example. Round 263,743 to the nearest thousands. Okay, let's write the number. And we need to round it to the nearest thousands, which is the thousands place digit for this number. This is the third 3 from the left, right? The second 3, okay. The 3 which is third from the left, okay? That one, the one which we have underlined. Now, remember what were the rules? The digits preceding 3, which are 2 and 6, we need to keep it as it is. So these two digits will go as it is in the final answer, 2 and 6. What about the digits which follow 3, the underlying digit that is? 7, 4, and 3, you replace each of them with a 0. So because there are 3 digits after 3, we replace it with 3 zeros, right? Each of them with a 0. Now we need to take a decision on the 3 itself, the underlying digit. For that, we need to look at 7. Because 7 is more than 5, the 3 will be increased by 1. Okay, we need to increase the underlying digit by 1. So 3 would now become 4. So 263,743 rounded to nearest thousands is 264,000, as you can see. Right? If you follow the rules meticulously, okay, as I said, you'll never go wrong. This is a very interesting method of doing it. Now let's take some special cases of rounding. Okay, what if the underlying digit is 9 and the number following that underlying digit is more than 5? Okay, let's take that case. So we need to round 782,961 to the nearest hundreds. So let's write the number as it is. And let's underline the hundreds place digit, which in this case is 9. Let's follow the rules. The digits preceding 9, which is 7, 8, and 2, we need to put them as it is in the final answer. So they will go as it is, 7, 8, 2. What about the digits following 9? Okay, we replace each of those digits by 0. So there are 2 digits following 9, 6, and 1. So each of them will be replaced by 0. So there'll be 2 zeros at the end. And what about the decision on 9 itself? Because the number next to 9, which is following 9 is 6, which is more than 5, we ideally have to increase 9 by 1, right? So if I increase 9 by 1, I'll get a 10, which is a 2-digit number. So what I'll do is I'll write 0 of 10 in the place where we had 9 and carry over the tens digit of 10, which is 1, to the preceding digit, which is 2. So 2 plus 1 is 3. So your final answer is 783,000. So the number 782,961 rounded to the nearest hundreds is 783,000. So please make sure this is a special case where if the underlying digit was 9, and if we were to increase that by 1, so because it will end up giving you a 10, you write the 0 of the 10 as it is in place of 9, and the 1 of 10, which is the tens place digit, will be carried over to the previous digit. And hence the 2, which was initially there in the number, becomes a 3 because we carried over that 1. I hope you understood how to round integers to a desired number of place values. Now, let's understand how to round decimals to a desired place value or a desired decimal place. Okay, the rules are largely the same except in one place. Okay, you'll understand which one. Okay, let's have a look at this example. Round 12.6347 to 2 decimal places. First, we'll write the same number as it is, 12.6347, which is the second decimal place. The second decimal place is 3 because it's the second digit to the right of the decimal, which is 3, right? So let's underline 3. Now, the first part of the rule is the same as the one we learned before for integers. So the digits preceding that underlying digit, including the decimal, you put them as it is. So 12.6 goes in as it is. So this is the same rule as before. Now, the tweak in the rule is for the digits following the underlying digit. So which are the digits following 3, 4, and 7? So in case of decimal rounding, you just ignore these digits. You don't replace them with 0. Okay, you just ignore them. You don't write these digits at all in the final answer. Okay, and then the call on the underlying digit will be taken as per the original rule, which means the same rule. So you look at the digit next to 3, which is 4. Because 4 is less than 5, you put 3 as it is. Okay, so you don't have to bother about any other digit. So that's your final answer. Okay, 12.63. So 12.6347 rounded to 2 decimal places is 12.63. Okay, let's look at one more example. Round 43.261 to 1 decimal place. Let's write the digits 43.261. And let's underline the first decimal place, which is 2. Right? We have underlined 2. Anything preceding 2, you put them as it is. So 43 point will go as it is. 43 and the decimal point will go as it is. What happens to the digits following 2? We just ignore them. Remember, this is decimal rounding. So we don't write the digits 6 and 1 at all. Okay, we just ignore them. Neither even we neither replace that by 0 either. Okay, which means 6 and 1 is just ignored. Okay, in case of integers, we replace them with 0. Here, you just don't put anything. What about the 2 then? Okay, how do we take a call on the 2? For that, I need to look at the next digit, which is 6. Because it is more than 5, the 2 will be increased by 1, and your final answer will then be 43.3. So 43.261 rounded to 1 decimal place is 43.3. Well, let's look at 2 special cases of rounding. The first case is where we use placeholders. Okay, let's look at that. Round 72.48 to the nearest thousandth. Well, which is the thousandth digit? Thousandth digit is the third decimal place, right? The third digit after decimals. So first, let us write this number 72.48 as it is. And we need to underline the thousandth digit. Hey, but where's the thousandth digit? We have the 10th digit, which is 4, the 100th digit, which is 8. Where's the thousandth digit? Well, there's no thousandth digit, and hence we need to use a placeholder, which is 0, to replace that. Okay, so your final answer will be 72.480. Right? Interesting, isn't it? So 72.48 rounded to nearest thousandth will be 72.480. And finally, let's look at this special case where the underlying digit is a 9. Okay, so 6.999 rounded to the nearest hundredth. Let's write the number as it is. The hundredth digit is the second decimal place, which is the middle 9. Okay, the 9 in the middle. Out of the 3 9s, the one in the middle is the hundredth digit. Let's follow the rules. The digits preceding 9, which is 6.9, will go as it is in the final answer. We ignored the last 9, right? Because we ignored anything that follows 9. And then the call on that 9, which is underlined, will be taken based on the next digit, which again is 9. Because 9 is more than 5, we need to increase the underlying digit by 1. So 9 when increased by 1 becomes 10. And you know what do? We write 0 of the 10 in place of 9, and we carry over the 1 to the preceding digit. Incidentally, the preceding digit itself is a 9 again. So 9 plus 1 is again 10. So we replace the second 9 also by 0. And the 1 of the 10, because we had 1 plus 9, 10, the tens place 1 will be carried over to 6. And finally, we get 1 plus 6, which is 7. So that's your final answer, 7.00. So 6.999 rounded to nearest hundredth is 7.00. Now, some of you may argue that what's wrong in writing simply as 7, because 7 is the same as 7.00. But that will be incorrect, because if I write 7, then you're rounding the number to the nearest whole. We need to round the number to the nearest hundredth, so we need to show 2 decimal places in the answer, even if they are zeros. So the correct answer is 7.00 and not 7. Make a note of that. Well, that's the end of this lesson. We learned what is the concept of rounding numbers. Remember the train station that we learned. Okay, so we understood rounding numbers is basically to round numbers to the nearest tens or hundreds. Okay, so which numbers go down and which numbers go up, okay, in terms of rounding. Then we understood how do we round integers to a desired number of place value. And finally, we learned how do we round decimals to a desired number of decimal places. We also considered some special cases in each one of them, remember? Well, I hope you understood all the concepts that was taught in this lesson. Thanks a lot.